Hello everyone, my name is Matthew Young. This is my discussion journal video presentation 1, and I have chosen to do problem number 8, which is to find the solution set of the given homogeneous system. So, first off, we want to set up the given set of equations into an augmented matrix. So we take all of the coefficients in every position and we place them into the matrix with the right side representing all of the zeros. And as we can see here, each column represents each of the variables. Column 1 is x sub 1, column 2 is x sub 2, and so on. So now we have to row reduce as far as possible in order to find a solution. So just to make things a little simpler for the rest of the row reducing process, I want to start by converting this negative one into a positive one, since it will be the position of our first leading one in just a little bit. So we multiply row 1 by the negative 1, and we get this new row where the negative 1's turned into 1's, the 2 turns into a negative 2, and the negative 3 turns into a 3. Now we can continue with our new matrix. We want to cancel the negative 1 and the 1 in the first column, so we take row 2 and we add row 1. Then we take row 3 and subtract row 1, which gives us our first leading one now that the rest of the column consists entirely of zeros. Now before we continue, I want you to look closely at the matrix we currently have. There's a row of all zeros, so we want to put that at the bottom of the matrix since it is now irrelevant. So we swap row 3 with row 4 to place the row of zeros at the bottom. Now we can continue row reducing. And since I want this 2 to be my next leading one, I have to cancel out this 1 above it. So how do I do that? Well, first I multiplied row 2 by 1/2, which gives me the new terms 1, negative 3 over 2, and 6. And now continuing on, now we can obtain our next leading one by canceling out the 1 in the first row by subtracting row 2 from row 1, giving us the new terms 0, negative 1/2, and negative 3. Now we're almost done here. We can obtain one more leading one in the position that I circled in blue by canceling out the negative 1/2 and the negative 3 over 2 sitting above it. So to do that, we multiply row 3 by 1/2 and add it to row 1. Then we multiply row 3 by 3 over 2 and add that to row 2. And we are left with 0, negative 5 over 2, another 0, and 15 over 2. Now there is one thing I actually wanted to point out. At first glance it does look like we can row reduce a little bit further since we have this 1 and these 2 entries above it. But we have to be careful because there's also this other one in row 3 that would mess up the zeros we have in column 3 if we were to add or subtract anything. And personally, I messed up this part during my first run through of the problem, so I thought it would be helpful to point it out. But other than that, the matrix on the right is now our final row reduced matrix. So the next step is to solve for the results of each variable. So in our matrix, we have leading ones for x sub 1, x sub 2, and x sub 3. So we want to convert the matrix back into equation form, the first row becoming x sub 1 minus 5 over 2 times x sub 4 equals 0, the second row becoming x sub 2 plus 15 over 2 times x sub 4 equals 0, and the third row becoming x sub 3 plus x sub 4 equals 0. Then we add or subtract to both sides in order to obtain the equations for x sub 1, x sub 2, and x sub 3. But now there's something else I want you to notice. All of our solutions are in terms of x sub 4, and we don't have a solution to x sub 4 since we weren't able to obtain a leading one for it while row reducing. So x sub 4 is now considered our free variable. So what do we do with the free variable? Well, we assigned a random variable equal to x sub 4, which I've just called s in this case. It really could just be any letter you prefer. So after we assigned s to x sub 4, we have to replace the rest of the x sub 4s in all of the other equations, which now leaves us with one last step. We want to put the solutions in vector form, so we simply factor out the s, leaving us with the coefficients 5 over 2, negative 15 over 2, negative 1, and 1, which ends problem 8 here. So to summarize, first we put the given homogeneous system of equations into an augmented matrix. Next, we row reduced as far as we could. Then we solved our new system of equations in order to obtain the results for our x sub 1, x sub 2, and x sub 3, and then x sub 4 as well. And lastly, we converted our results into vector form. So thank you all for watching, and I'd be pleased to read any comments you may have for my solution.